We now look at real world applications, right? These are word type of problems. The first applied example 1 appears on page 75 of your text. So we have a manufacturing production scheduling problem. So the company Ace Novelty wishes to produce 3 types of souvenirs, right? And they're calling them types A, B, and C. To manufacture a type A souvenir, it requires 2 minutes on machine 1, 1 minute on machine 2, and 2 minutes on machine 3. A type B souvenir requires 1 minute on machine 1, 3 minutes on machine 2, and 1 minute on machine 3. A type C souvenir requires 1 minute on machine 1, 2 minutes on each of machines 2 and 3. And then we are told that there are 3 hours available on machine 1, 5 hours available on machine 2, and 4 hours available on machine 3 for processing the order. Right? And the question is, how many souvenirs of each type should Ace Novelty make in order to use all the available time? It says formulate, but do not solve the problem. We will solve this problem in example 7 in section 2.2. Right. So let's introduce the variables. So let x equal to the number of type A souvenirs, y equal to the number of type B souvenirs, and z equal to the number of type C souvenirs. Okay, that comes from the part in orange that's underlined in orange. Okay, now to take all the information that was underlined, we can put the information in table form, in a table like this. So we've got items, right? So we'll write the items under the items column. So we've got souvenirs of type A, type B, type C, right? And then we've got the number and we know that we called numbers X, Y, and Z, the number of each of these types of souvenirs. Now we look at the processes that are involved, right? We've got 3 machines. Machine 1, and we can look at the time in minutes. Machine 2, again the time in minutes. And then machine 3, the time in minutes. Right, so if we go back for the type A souvenir, right, it's underlined in light blue. So it's 2 minutes on machine 1, 1 minute on machine 2, and 2 minutes in machine 3. So here we can put in 2, 1, 2, the time in minutes. The same now if you look at the type B souvenirs, right? The part that's underlined in green, dark green, it's 1, 3, 1 in each of those, the number of minutes in each of those machines, machine 1, 2, and 3. Then you can go to the type C souvenir, right? It's underlined in light green. It's 1 minute on the machine 1, 2 minutes on machine 2, and 3. So 2 minutes on each of machines 2 and 3. So light green going to be 1, 2, 2. Then if we look at the part in red, it's the availability given in hours for machine 1, 2, and 3. So we're looking at the part in red, it's underlined in red, the availability. So remember that for each item, the time is in minutes. So we need to convert this time in minutes. So for the first machine, it's 3 hours that's available. So it's 3 times 60. For the second machine, 5 hours. So it's 5 times 60. And similarly for the third machine. Now, we want to know how many souvenirs of each type should Ace Novelty make in order to use all the available time. So here, the constraints, right? If we look at the constraint from machine 1, your 2x plus y plus z must equal to 180. So from machine 1, that's 2x plus y plus z is equal to 180. From machine 2, it's x plus 3y plus 2z is equal to 300. And from machine 3, it's going to be 2x plus y plus 2z is equal to 240. Okay, that's, they wanted us to formulate but not solve the problem. So this is the formulation of the model. We end up with 3 linear equations in 3 unknowns. Right, we move on now to the next problem. Investment Club, this is on page 76. It's problem number 22 in the text. A private investment club has $200,000 earmarked for investment in stocks. To arrive at an acceptable overall level of risk, the stocks that management is considering have been classified into 3 categories. Right? is a high risk, medium risk, and low risk. Now, management estimates that the high risk stocks will have a rate of return of 15% a year. Medium risk stocks, 10% a year, and low risk stocks, 6% a year. The members have decided that the investment in low risk stocks should be equal to the sum of the investments of the other two categories. And what we are required to do is determine how much of the club, how much the club should invest in each type of stock if the investment goal is to have a return of $20,000 a year on the total investment. And we are asked to assume that all the money available for investment is invested. Right? You should stop the video and then set up the table and get the constraints out. I'm now going to continue. So if we look at this, we've got stocks, and we are given information on the amount to be invested in dollars. Right? So there are three types of stocks: high risk, medium risk, and low risk. We'll let the amount to be invested in each of these stocks in dollars be X, Y, and Z. And we know that the total amount for investment, so the total investment is 200,000. And of course, we want all the money to be invested. So your condition one, you're going to have X plus Y plus Z is equal to 200,000. condition 2, let's look at the part that says the investment, the part in green, the investment in low risk stocks should equal to the sum of the investments in the stocks of the other two. Working with the part in green, this is concerning the investment. So the investment in low risk stocks should equal to the sum of the investments in the other two. So in terms of the unknowns, it's going to be Z is equal to X plus Y. Okay, so let's go back. The part in purple, management estimates that high risk stocks will have a return of 15% a year, medium risk 10% a year, and low risk stocks 6% a year. So working with the part in purple, condition 3, right? 15% a year for high risk stocks. So it's going to be 0.15 of X plus 10% for medium risk stocks. So it's going to be 0.1 Y plus 6% for the low risk stocks. It's 0.06 of Z. And we want a return. The investment goal is to have a return of 20% per year. Sorry, $20,000 per year. Right, that's coming from the part in red. So this must equal to 20,000. Well, I'll fix that up in the P. Okay, it's fine. The 20,000. So if we're formulating the problem, that's what we're trying to concentrate on. It's this, the system of equations to solve the problem. Right, working with the three conditions, this is what we end up with. In the first condition, from the second condition, right? And you could take the variables from the right hand side to the left hand side so that you get them under in the same column. Working with the third condition, if we multiply throughout by 100, then you're going to get 15x plus 10y plus 6z is equal to okay, that's 2 million. You need to practice these types of problems. We will stop at this stage.